Lesson 5-3, greatest common factor, and in this lesson you learn to find the greatest common factor of two or more numbers. When are you ever going to use this? Knowing how to find the GCF, or the greatest common factor of two or more numbers, can help you coordinate a parade. Okay, so the term that we are going to learn for this lesson will be the greatest common factor, or GCF. Suppose that 27 flag line and 47 drill team members were selected to participate in the Flag Day Parade. The parade director wants all members to line up in rows that have the same number of people. Flag line and drill teams will be in different rows. What is the greatest number of people that can be in each row? Okay, so to answer this question, you can use the factors of 27 and 45. So let's list the factors of 27, 1, 3, 9, and 27. Factors of 45 are 1, 3, 5, 9, 15, and 45. Okay, so if you notice, 1, 3, and 9 are common factors of both 27 and 45. And the greatest of the common factors of the two or more numbers is called the greatest common factor of the numbers. So the greatest common factor of 27 and 45 is 9 right here. Okay? So 9 is the GCF of 27 and 45. Okay? So in this case, going back to this problem, okay, we know that the greatest number of people that can be in each row will be 9. Okay, so to find the GCF of two or more numbers, you can make a list or use prime factorization. And let's use a list first, and I'll teach you how to do prime factorization. So a list, what is entailed in creating a list? Of course, list all the factors of each number. Okay, then identify the common factors. Just as we did here, we listed all the factors of 27, 1, 3, 9, 27, 1, 3, 5, 9, 15, and 45 for the number 45. And then we identified the common factors. Those are the ones in blue. Okay, and then after identifying the common factors, okay, the greatest of the common factors is the GCF, and that's how we identified 9 as the GCF of the two numbers. Okay, the next method, which is the one that we would be using a lot, is using prime factorization to find the GCF method. Let's look at this method. Write the prime factorization of each number. Identify all of the common prime factors, and the product of the prime factors is the GCF. Okay, how do we do this? Let's take a look at the example that we just had, 27 and 45. So I'm going to write 27, okay, right here, and 45. It says there, write the prime factorization of each number. So we get 27, and we do our factor tree. Okay, and in our factor tree, get any two factors of 27. Let me extend this further. There you go. Get that down a little bit. Okay, so any two factors of 27, let me take that thing out. Okay, so any two factors of 27 will be 3 times 9. And we know that 3 is prime. I circle 3, I stop factoring. 9 is prime, so I continue factoring. That's 3 and 3. Both of them are prime. And we put the point there as multiplication. Okay, so the prime factors of 27 are 3 times 3 times 3. Let's take a look at 45. In 45, I'm going to use the drop-down method instead of the factor tree this time. So the least prime factor that 45 is divisible by is the number 3. 45 divided by 3 is 15. 15 is not prime because it ends in 5. And the least prime number that can go into 15 is 3. 15 divided by 3 is 5. Okay, and we know that 5 is prime. We stop factoring. So the prime factors of 45 are 3 times 3 times 5. And it says here that identify all of the common prime factors. Okay, so we identify it by circling the common factors. That's common, and that's common. And the last one, the product of the common prime factors, is the GCF. So we bring that 3 down once, bring this 3 down once, multiply them, you end up with 9. And that's how you find the GCF of 27 and 45 using prime factorization. Okay? Now, pause or rewind if you need to understand prime factorization, to understand finding the GCF using prime factorization, because again, this will be very important. Okay? Let's take a look at example. Let's take a look at example number 1. Here's example number 1. I think it's at the bottom. Okay. Let's take a look at this. Where is that example number 1? Well, I don't think we have example number 1, but we have example number 2. Okay, so we'll do example number 1 at the very bottom of this page. Okay, let's take a look at example number 1. And example number 1 says find the GCF of 24 and 32 by creating a list. So we want to find the GCF, okay, of 24 and 32 by creating a list. Okay, so let's find the factors of 24. Factors of 24 will be 1 times 24, okay, is 24. 2 times 12 is 24. What else? 3 times 8 is 24. And 4 times 6 is 24. Okay, so these are all the factors of 24, and we are using the listing method. Let's find the prime factors of 32. 1 times 32 will give us 32. 2 times 16 will give us 32. It's not divisible by 3 because 3 plus 2 is 5. So we go to 4 and 8. 4 times 8 will give us 32. Okay. Let me erase that. Let me bring them closer together. 4 and 8. Let me grab these numbers, bring them closer together. There we go. Okay. And let's look at the common factors. Okay. Obviously, we're not going to use 1 as a common factor, but we have 2. That's a common factor. 4 is a common factor, and 8 is a common factor. But the greatest common factor using the listing method would be 8 right there. So the GCF of 24 and 32 would be 8 using listing. Okay, let's take a look at example 2. This one I was able to put up there. Oops, not that one, this one. Okay, we want to find the GCF of 36 and 54 by using prime factorization. Okay, so using the factor tree for both, let's find 2 factors of 36. Since 36 is an even number, we can use 2. So 2 times 18 would do. 2 is a prime number, so we stop factoring. But we know that 18 is not prime, so we continue factoring. 2 times 9 is 18. 2 is prime, but 9 is not. So we continue factoring until we all get the prime factors. The prime factorization of 36 is 2 times 2 times 3 times 3. Okay, so I'm going to write this down here on the side. Okay, this is 2 times 2 times 3 times 3. Okay, using the factor tree for 54, let's get 2 factors of 54, 2 and 27. Okay, so 2 is prime, so we continue factoring because we know that 27 is not prime. We know this because 2 plus 7 is 9, and that means this is divisible by 3. 2 factors of 27 are 3 and 9. 3 is prime, we know that. 9 is not. We continue factoring until we get 3 threes. or 3 times 3. So 2 times 3 times 3 times 3 will be factors of 54. Now you have 2 times 3 times 3 times 3. Okay? And we simply get the common factors. We circle them. We circle them. And we circle them. Bring them down once. I bring down 2 ones. I bring down the 3 ones. And I bring the other 3 ones. Multiply all of them. That would be 18. So the GCF of 36 and 54 is actually 18. Okay? There you go. In life science, example number 3, last example. Kaja has 32 fir, 48 cedar, and 84 maple tree seedlings to sell at the annual agriculture fair. He wants to display them in rows with the same number of seedlings in each row with no mixing of rows. What is the greatest number of seedlings that he could put in each row? Okay, that's the first question. Okay, and that's just finding the GCF. And letter B, how many rows of each seedlings will there be? So let's answer the first question because we cannot answer A. We cannot answer B without answering A. So let's take a look at the factors of 32. 1, 2, 4, 6, 1, 2, 4, 8, 16, and 32. The factors of 48 are such, and the factors of 80 are such. Now, if you notice, if you're doing this on your own, okay, listing the factors can sometimes be very tedious, and sometimes you can forget factors, and that's why that this is not the recommended method of finding the GCF. And I'll show you how to find the recommended method after we do letter A. Okay, so we find our common factors 1, 2, 4, 8, and 16. And the GCF, the greatest of those factors, will be 16. Okay, so therefore Kaja could put 16 seedlings in a row. Okay, and let's see how to find the common factors of 32, 48, and 32, 48, and 80 using prime factorization. Okay, I'm just going to use the drop down method for this one. So for 32, I'm going to write it here, drop down method. First prime factor that goes into the 32 would be 2. 32 divided by 2 is 16. 16 prime number that goes into 16 would be 2 again. 16 divided by 2 is 8. Okay, prime factor that goes into 8 would be 2. That would be 4. Okay, 2 and 2. So the prime factors of 32 would be 2 times 2 times 2 times 2 times 2. Let's take a look at 48. Okay, using the drop down method again. Prime number that goes into 48 is 2. This is 24. Prime number goes into 2. 24 is 2. That'll be 12. Okay, 12 is not prime still because it's still even. That means it's divisible by 2. 12 divided by 2 is 6. And 6 is still not even. 6 divided by 2 would give you 3. I'm sorry, 6 is even. Okay, so in this case, prime factorization of 48 would be 2 times 2 times 2 times 2 times 3. And let's take a look at the number 80. Okay, even divisible by 2, so that gives us 40. Even divisible by 2, that gives us 20. Even divisible by 2, that gives us 10. Even divisible by 2, that gives us 5. All are prime factors. So now I have 2 times 2 times 2 times 2 times 5. Okay, and we simply circle the common factors for all 3. This is common for all 3. Common to all 3. Common to all 3. Common to all 3. And I simply bring that down once. 2, 2, 2, and 2, and I multiply all of them. I end up with 16. Okay, so this is how you find the GCF of 32, 48, and 80 using prime factorization. Okay, knowing that, let's now answer letter B. How many rows of each tree seedlings will there be? Okay, since 2 times 16 equals 32, there would be 2 rows of fir seedlings. Again, using the GCF. Since 3 times 16 equals 48, there would be 3 rows of cedar seedlings. And since 5 times 16 equals 80, there would be 5 rows of maple seedlings. Okay? And that's how you answer that particular example. And that's the end of our lesson on GCF. Thank you for watching.